Okay, now that we have deployed our microservices into EKS cluster, let's talk about the challenges of microservices architecture. So let's see the diagram here. So this is a microservices architecture. Let's say we have three pods. Okay, these are pods. The outer container is a pod, and then we have a microservices container running inside a pod. Okay, in each of these pods. So if we see the microservice, so we have the microservices business logic, then we have the communication logic. So this communication logic is basically the logic that defines how one microservice should communicate with other microservice. And then we have a security logic, the retry logic. So in case of microservices failure, how do we want to, impose the retry logic? So that's another logic. Then we have the metrics, the tracing, and all this kind of other logics. So it looks like our microservices is overloaded with non-business logic. So instead, we could only have the business logic in our microservices and make it lightweight. So it would make more sense to take this other non-business logic out of this microservice and then just have the business logic in the microservice. Okay, so that's one of the problems, and the solution to that is service mesh. So basically, in service mesh, they have a concept or the design pattern called sidecar proxy. So basically, if you consider this as a pod, this square as a pod, and then we have a microservice container running inside it, then this microservice container is a motorbike and it has only the business logic. Okay, and the non-business logic is we can inject another container called a sidecar, and then the non-business logic we can write in this sidecar or the proxy service. Okay, so this is a sidecar proxy, and it definitely makes sense to extract out all the non-business logic in a separate proxy service. So if you see here, this sidecar is a separate proxy service that is going to extract out all the non-business logic from the actual microservice. Okay, so that is the service mesh solution. Now let's understand a few more things about service mesh. So once we do this, so within a pod, we're gonna have a microservice as one container, and we're gonna have another container called a proxy or an envoy proxy that basically is going to have all these non-business logics. Okay, so this is a sidecar proxy. This handles all this networking logic, and also the good thing is that now the developers can focus on the actual business logic for developing the microservices, and they don't have to write all this communication or security logic in each of the microservices, because this is a redundant task, because we need to repeat the same thing in all this microservice. So that's the solution. And one of the implementations of service mesh is Istio. This is the open source and very powerful service mesh solution, and most popular. This is founded by Google, IBM, and Lyft in 2016, and then it is a graduated project in the Cloud Native Computing Foundation alongside projects like Kubernetes and Prometheus. Now, this Istio has its own control plane, just like the Kubernetes control plane. It's going to have its own control plane, and then that automatically is going to inject these proxy containers in every microservice pod. Okay, so if you see here, or you can go down here. Okay, so this is a control plane of Istio control plane. Okay, and then this is going to automatically inject these proxy containers in each of these microservice. Okay, now, and this is actually separate from the manifest file we have created already. So this is like two different things. Okay, service mesh is so we don't have to make any changes on the existing Kubernetes manifest file, so we can have different manifest file for service mesh. Now, once we inject these proxies, now this communication between this service and another service is not going to be direct. Now in this case, it's going to be through the proxy. The communication between the services or the microservices is going to be through the proxy. Now you can have some security logic in each of these proxies, and then that is how you can make your microservices more secure. That's one use case. So another use case is traffic splitting. So you can use Istio in order to split the traffic into multiple versions of your application. Let's say you have a currency service microservice, and then you have three different versions: version 1, 2.0, and 3.0. And then let's say this is the latest version, and then you want to make sure that only 10% of the traffic goes to this newly created service, and then 90% of the traffic should go to the the older versions of this currency service. So this is something you can achieve with Istio features. With Istio service mesh. Okay. Now another features is service discovery. So you can discover your services. Basically, you can see how many services are up and running. How are all these services healthy, or is any of your services down? So this is called service discovery. This is something we can um, achieve with Istio, and this is what we're going to look at later. So we're going to set up Istio in our EKS cluster, and then we're going to inject these sidecar proxies to our pods. Then they're going to collect the information from the pods, and then we can visualize through one dashboard service called Kayali. That's what we're going to do. Okay, so another one is security, which we just talked about, and then metrics and tracing. Also, we can do this using Istio. So for this demo, we're just going to cover service discovery, but these are the important features of service mesh. Okay, now we're going to do that. Okay, so this is the steps on how to access Kayali dashboard. Okay, we're gonna see how this service discovery features is we can leverage this feature using Istio. Okay,